Saxon Math 7-6, Lesson 90. The topic is geometric formulas. Okay, a couple things I want to say about geometric. Geometry is the study of shapes, and in some math books they pull algebra and geometry into two different books and pretend like they're two separate unrelated problems. In the Saxon curriculum, which you know is, for my money, the only curriculum worth using, I have very strong opinions about it. Geometry and algebra are left together because John believes that there isn't really a distinct line between the two of them. There's certainly differences between pure geometry and pure algebra, but very often in our problems, they blend and merge together. So what John does is he just throws some algebra and some geometry in, which is what we've been doing already, and we'll continue to do. So geometry just means the study of shapes, and we're commingling it with our algebra. Formulas are, that's when you know this is what upper level mathematics is all about, is using formulas, which are tools, to help us solve problems. And I would probably say it the other way around. It helps us organize our thinking so that we know how to solve problems. So we're going to start working directly with formulas, and here's my rule for formulas. In the end, you have to memorize them. Okay, that's our goal. But rather than writing them on flashcards and trying to, drill yourself, what I want you to do is write them inside your homework notebook cover. I'll show you what I mean. Well, shoot, my examples are terrible. The problem I have with this is that most of my notebooks have a plastic cover, and you can't write on that. What I would normally want you to do is just flip open your book, and if you have cardboard, then this should be just like the brownish raw paper cover. You can write right on that. This one isn't bad because I've got a cardboard cover in the back that I can use to write my formulas on. I could also write some on the back. You'll see this was originally Natalie Smith's book that I used with her, and now I use it for Jayla and Lydia. So, but use this. If you're like me and you have these plasticky notebooks, then maybe you can take a piece of paper and tuck it in the front pocket or something like that. You'll have to improvise if you have plastic. But write them in your notebook. Then, whenever you run into a problem in which you need to refer to that formula, you've got it right there in your notebook, right? Nice and handy, close by. And as you fill in one homework notebook and move on to the next, you'll have to copy your formulas into the new notebook, but that's okay. That will help you memorize them. And guess what? You're going to trick yourself into memorizing these, because as time goes on, you're going to be so lazy that you're not even going to want to flip from the page that you're on doing your homework to the cover to look at it, and it's going to force you to memorize it. You'll just do it. I promise you. It'll just happen. So whenever I introduce formulas, the long-term goal is to memorize them. The short-term strategy is to write them inside your notebook, your homework notebook cover, and collect them there. Okay, that's enough talking about that. Are you ready? Formulas use abbreviations, so we have to make sure that we know what our abbreviation is. In these formulas, perimeter, the outside edge, that's what we're letting P be equal to, right? So what we're going to be doing is we're going to be making a chart. I'm going to make it on the next page. I'm just going to write down what some of these abbreviations are, and it'll make sense to you as we go. P stands for perimeter, A stands for area, those are uppercase. This stands for length. It's a cursive L, which I know you're probably like, cursive? What is this strange thing you speak of? But we can't use a regular lowercase l because it looks like a 1, and that's just going to confuse us. So you get to practice making a lowercase l. That will stand for length. And then here's a W. That will stand for width. B will stand for base. H will stand for height. This is just kind of like a key. You don't have to know anything about these words yet. Just looking at them all. Yes. Okay. So now, set those aside. By the way, if you don't have paper and pencil, run, go, get right now, because I want you to write this out with me. And I don't want you to copy it directly into your notebook cover this time. I want you to copy it onto a piece of paper, and then when you understand it, you can copy it into your notebook, and it will make more sense to you. So I'll wait right now while you go get paper and pencil, or whatever you want to write with. I don't care if it's pencil. Go get something to write with and a piece of paper so you can do this with me. Okay, go. I hope you paused me, and I hope you're back now. We're going to create a chart that has some cool formulas. All right, I think this is going to be big enough. Make it about half the page. One thing about formulas that's always true is you want to write them big and legibly so that when you're in the middle of a problem and you're like, ugh, what's that formula? You won't overtax your brain by having to look through a bunch of tiny scribbles and figure out what you wrote. So Joel in particular, neatness counts for this, all right? I'm making one skinny row and then a total of 4 fatter rows. They don't have to be exactly the same, but that's the idea. Then we're going to make them into 3 columns, and I'm going to make my middle column a little bit bigger. This one's a little bigger, this one's medium. That's Baby Bear right there. All right? Pause me at any time if I'm going too fast and you need to have a little bit more time to draw. Across the top, I'm going to write shape. And I'm going to write perimeter. And I'm going to write area. And then down the sides, I'm going to write. That's a cat wanting in. I didn't have quite room to write parallelogram all on one line. That's okay. Hi, Wonton, you want to come in? Come in. I mean, I'll interrupt a math video to let my cat in, wouldn't you? Of course you would. Feel free to pause me anytime your pets need to. Okay, so these are the 4 different shapes that we're going to be working on, and we're going to write down formulas for their perimeter and for their area, okay? So let's think about squares first. A square has 4 even sides, right? I'm going to draw a little one right there. They're the even ones. So the perimeter of this square is to add up all 4 sides. So we can shorthand that formula by saying if you just take the length of one side and multiply it by 4, that will give you the perimeter. Does that make sense? Again, going around the edge. Rectangle. With a rectangle, they're not all the same. There's a long side and a wider, so there's a length and a width is the way we usually say it. So to get the perimeter for this, we take 2 times the long side, this is equals, plus 2 times the width, right? So 2 of those, add them all together, that gives you the perimeter of a rectangle. Triangle, well, triangles can look exactly the same, but sometimes they don't. Let's make sort of a wonky triangle. We're just going to say that you add up the sides Side 1, side 2, and side 3. And we can't make any assumption that they're the same or not the same, because triangles can be different. Squares are always going to have the same length of side all the way around. So with a triangle, you just add up the 3 sides. And with a parallelogram, which is, I'm drawing this one out of the box, okay, we would do the base and then 2 times the side, calling this the base and this the side. All right? Parallelograms somehow made their way into this chart. I personally would like it better if we just stopped with triangle, but John wants to talk about parallelograms too, so we'll throw those in there, but it's these top 3 that we're going to use a whole lot. All right, so these are all formulas for the outside edge of the shape. Now let's talk about the formulas to find the area, the space that the shape takes up. So again, basic area is when we multiply side times side, right? Let's start with the rectangle first. The area equals the length times the width. We know that one, we've used that one. With a square, it's the same idea. It's the length times the width, but because in a square all the sides are the same, we can write it in a different shorthand. It's the side squared, right? Because whatever this number is, that will be the same. So even if it's 8 times 8 or 1 times 1, we can just write it shorter if we write it that way. For a triangle, the area, we take the base times the height, and then we divide it by 2. Okay? I think we've talked a little bit about this. We're going to talk about it a whole lot more. You don't worry about it. And the same with the parallelogram. We haven't talked about this one as much, but it's base times height. Okay? So here what we have are all 4 all 4 formulas for area, and then we have a key, which is what we wrote on this page, that helps you remember what all those letters stand for. Oh, here's one we didn't get. S equals side. Okay? So, that's all we have. No, that's not true. Problem. Let's look at it. But before I move on, I want to say this. This is 90.1. I want you to copy this chart into your notebook. And I want you to realize that you're going to start committing these to memory just because we're going to be using them more and more. You don't have to start any special project to study them. Don't worry about that. The other thing that I wanted to say that I forgot to say in lesson 89 is these investigations that sometimes pop up in the book. We've had them before. It was investigation number 3 in lesson 89. We're not going to do it. Just cross it right off, okay? We've got enough on our plate. We don't need to do the extra activities. Life is short, people. We got to make the most of it. Okay, so if you see that in the book and you think, wait, what? Don't worry about it. We're not doing it. Now, back to lesson 90, or example 90.1. Write the formula for the perimeter of a rectangle. Okay, so let's find that first. Perimeter of a rectangle. Rectangle perimeter. Okay, so let's write it. P equals 2 times the length plus 2 times the width. When you memorize a formula, I don't want you to say 2L plus 2W, because now you don't know what it means. Perimeter equals 2 times the length plus 2 times the width. That's how you memorize it, all right? I will use them that way. Perimeter equals 2 times the length plus 2 times the width. Then substitute in 8 centimeters for the length. So here's the way we do it. L equals 8 and 5 centimeters for the width. Okay, so we write down the variables. Solve the equation to find P. So now we plug in. P equals 2, and notice what I do. Where there was a letter, I put a pair of parentheses. It's like a bucket. And then we say L equals 8, so now I pour the contents of that bucket into this L shaped space, and we'll be able to solve this. 2, and then here's the W bucket, and it says W equals 5, so we pour the 5 in there. All right, this is going well. Now let's see, order of operation. Should we add first or do these multiplyings? Let's do the multiplyings. P equals 16 plus 10. P equals 26. Geometry always has units. So we look back at the problem and say, what's our unit here? Centimeters. This is perimeter, so it measures the outside edge, so it's not going to be squared. It's just a single unit of length. Perimeter equals 26 centimeters. Yay, that's the right answer. Okay, so this is a perfect example of how we use the formulas to solve problems. They're tools that shortcut us straight into the problem. We don't have to stop and look at the shape and puzzle about it. If we know the formula, we can just jump right in. Yay. We'll be using them a lot. Don't worry. They'll be beaten into your brain. But that is the purpose of lesson 90. So again, make sure you copy this onto one of the covers of your notebooks and keep it handy so that when you need them, they'll be right close by. Okay, good job, you guys. Thanks.